Well, hi folks, this is Darren with MyRV Works, and today I want to talk with you or share with you a little bit about tanks, monitor panels, sensors, things like that. So I've got a black tank here, or a gray tank, it could be either. I've got a monitor panel to play with and do a demonstration on, and I've got some sensors and some harnesses, and that's what we're going to get into. We're going to get into how all this works, how to troubleshoot it, and maybe understand a little bit more about how these things would fail and give you a 2/3 value when it's really a third or empty. Now, the way this video came about, I have an RV that I was going to be modifying, and I was going to put this tank in it. And I got a brand new KIB monitor panel, and it turns out that I made a discovery about this monitor panel. And in my discovery of my own diagnosis on my own time on my own RV, I found something out about this that I figured, well, hey, this is worthy of setting up the camera and getting all this laid out here. So let me bring you in a little bit closer, and we'll show you a little bit of show and tell on what we're working with, okay? So this would be a typical tank that you might find in your RV. Typically, they're found underneath. You are usually used to the discharge, okay? This is where your termination valve would be with the handle or the cable. I might even do a little demonstration on that. Probably what I'll do is I've got a lot of information on these things, so I'll probably break it up into several different videos. So one video is not like an hour long, they'll be shorter little videos. And so I think what I might do is that. So anyway, but let's just stay focused here. So this is the coloring. So if you're gonna go with the KIB system, and what we're talking about is these little sensors like this, okay? And we're gonna show you how these work. There are other products on the market that use different types of sensors. This video is about the type of monitor panel that uses these little buttons that you push, and they're going to talk to these types of sensors. That's what this is going to be about. Maybe I'll make other videos that talk about different things. White is going to be your ground common reference, okay? And then when the tank is filling up and it makes a connection of liquid between the white and the yellow, then you're going to get a 1/3 value on your monitor panel. We're going to go into all that here in just a second. And then as it fills up, it's going to make a connection between the white and the green, and then the white and the orange to give you full. Okay? So that's what's going on here. Now, they all have a common white as your reference, and then all of these little harnesses are going to have a red signal wire. Okay, so that is to say, if you have a black tank, a gray tank, and a freshwater tank, as this monitor panel has a gray, black, and fresh, then you're going to have 3 of these harnesses. Here we have them, 1, 2, 3. Okay, 3 of these little wire harnesses, and they're all going to have the exact same common. Okay, but the red signal wire from all of these individual sending units, okay, will connect to different monitor wires to indicate this. So now that we understand the color code on our tank, let's move the tank out of the way. We're going to come back and visit these here in just a second, but I just want to introduce you to all the characters in the story here. Okay, so here we have the typical monitor panel. They come in different shapes and sizes, different colors and things like that. But with this type of system, you're going to push the button. The beautiful thing about this system is it doesn't pull much power, and any power that it does consume to give you the reading on your LED lights is only when you push the button. Okay, so when you're not pushing the button, there is no draw on your battery. So that's what's wonderful about these things, okay, is it's not a system that's going to consume a lot of power, okay. They're very popular. They've been around forever. I've seen them in a lot of RVs. Now on the back, you do have a whole big mess of wiring, but let's just kind of simplify this. Coming out of this motherboard, that's all we're going to focus on. We're going to ignore every other wire, okay. So coming out of this motherboard, look here, we've got red. Let me pull red out. Okay, we've got a red, a white, a gray, a brown, and a blue. Okay, so that's really simple. That's nothing scary. Red is going to be 12 volts plus. White is going to be 12 volts minus. So that leaves us with these 3 wires. Now on this monitor panel, we have a gray tank, a black tank, and a freshwater. We're going to ignore battery for now. We're just talking about tanks, okay? So we have gray, black, and fresh. So here we have gray. The gray tank is the gray wire, the black tank is a brown wire, and the fresh tank is the blue wire. If you have a monitor panel that's got another tank, typically that wire will be black, okay? So we've pretty much simplified this. So we're going to give this 12 volts plus and minus, and then the 3 harnesses that we have right down in there, we would connect those. Their red wire is not the same red wire as this red wire. Their red wire is going to connect to the ends of these for the different tanks that you want to read from that sending unit. Okay? So the other end of these sending units, so we now know, we've understood a little bit more about how this works, and so, or how the wiring of it is. And so on this, we would have the sensors. Now we would have, let me just take this one off. There we go. So the other end of, we've established that this red wire is the one that's coming from the sending unit. Inside of here you have resistors, and I will be demonstrating the different resistor value that we get from this. And so what that means is I'm going to be sending 12 volts down a wire, and it's going to be coming back to me with a different voltage reading, and from that rectification of the voltage, we were able to send that to here. Very simple. It's been working wonderfully for many, many, many years. These sensors, the way these work, I'm going to take one off. And so it's just a simple little grommet thing, okay? I could probably tell you the size. It looks like a 1032 thread. And if I were to take this off, all we have is, wait for it, okay, there we go. Look, it's just basically a screw, isn't it? It doesn't have the, it's just a screw. It doesn't have the slot or anything, but that's the sensing end of it, and it's just a screw. There's nothing special about this thing. So what they then do is they then have a rubber little expandable gooey thing. They put a flat washer on the end and a nut. Okay, so nothing special about that. There's nothing that could break on this. It's stainless steel. So when these get tightened, so what you would do is in your tank, you would drill a 3/8 hole at slow speed, okay, and you would insert this into it. You would take a 3/8 wrench and you would tighten it. Let me grab the other end of this thing. And you would tighten this. Now what I want you to watch is to watch how that deforms, okay? So as I'm tightening this, you'll see that it's kind of made a little bit of a bulge as opposed to the one that's not. That's how it goes into the hole, and it expands, and it basically keeps the water in. Now, if one of these sensors should fail or you want to upgrade it to a different type of a sensor, honestly, I would leave this alone, and I would just drill a hole right next to it. Okay, so I would orphan this sensor in place in my tank, and I would drill a hole right next to this one, and that's where my new sensor would go. There are some aftermarket sensors. These are two that are very popular. It's called the Hurst Miracle Probes. This one would be one that you would use for your black tank. And here it's the same concept with the thing that bulges, but the business end is out a little bit more on the tip here. And this would be used for a black tank. On this end, they have a little bit of a profile on that, so where you know when it goes to the tank which way this hood is oriented. And the idea is here is in your toilet paper, something would land on this Teflon piece and not interfere with the sensor. Okay, this would be one that they might use for gray water or fresh water. And again, the tip is way out here. This is a rod that sticks out, but right where my fingertip is, this is all plastic coated. And then the sensor end is way out here. So instead of it being right away here, they move the sensor out. And that helps get a little bit better sensor readings. Okay, so we've talked about these. Moving on, okay, I don't want to waste anybody's time. So what I want to show you now is a little bit of the magic on how the system works. So I'm going to reposition the camera a little bit. And so we've understood all the characters in our story. And if you'd like more information, do shoot me a text and say, Darren, could you go a little bit more into detail on this or that? And I'll be happy to do it. So what I want to do now is show you how this monitor system works. And then the biggie here, the big part of the show, is a fault that I found right out of the factory, right out of the box. We have an out-of-box failure, and I want to show you that. Okay, so let me reposition my camera. Now, I want to go a little bit deeper into what's going on with these things. And so I've got everybody closed on. This is a document that I will make a link to. It's their monitor panel information, how to wire them. The sensor is called a MP5. It talks about tightening them to 100 ounces, and when you're done, to spray them with some battery or silicone sealer on the tips of the tank here. So, but what we're looking at is this part up here. Now, what it's going to say is the Pigtail test procedure. So the pigtail can be tested with an ohm meter as follows. So red to orange, red to green, red to yellow. Okay, so here we're going to go red to orange, green, and yellow, and then we should get for red to orange 0 ohms, red to green 68 ohms, and red to yellow 1,000 k ohms. Okay, so now when I did this, I made a huge discovery. Here I've got my Fluke meter. It's been in almost all my videos. This is my everyday carry meter. It's a Fluke 325. And when I just said, okay, well here, this will be great. Let me do that. So polarity does not matter. So I'm just going to use, they say red to orange. So red to orange, I expect to get 0 ohms of resistance. Okay, so let's do that. I have 0 ohms of resistance. And the thing's beeping. So, yay, we got a victory. Okay, but let's move on over here to red to green. Red to green, I'm expected to get 68,000 ohms of resistance. So red to green, it's saying open loop. Oh, well, you see that? Oh, well. I don't know if there's a glare or not, but it shows oh, well on red to green. Right away, I would assume that the sensors are bad. The sending unit's bad. So let's go on to red to yellow. Okay. And I'm supposed to have 188 k ohms, and I have open loop. Oh, well. And I'm like, well, that's strange. I wonder if the sensor's bad. So I've got 3 of these sensors, and I got the same reading. So let me show you what I did. It's very exciting. Hold on for a second. Okay, so we started off with my everyday carry meter here telling me that I got an open loop, and I'm supposed to be getting, I'm red to yellow here. Now, red to yellow is supposed to be 188K. Okay. That's supposed to be 188K. So I started to get all my other meters. Each one of these meters could tell a story. This was when I was doing airport automation. This was for Spirit Aero System on the 787. This was greenhouse automation. They're all different stories. I've been doing engineering type systems for over 30 years. So each one of these could tell a story. But I expected that to give me my ohms value. I even went and got my oscilloscope, okay? So then I started moving. Let's turn all these on to ohms. Okay, you see where we're going here. All right, this one's broken. I discovered that. So everybody's set to ohms. Okay, so I've got all these meters turned on to ohms. And what I'm expecting is 188K. So I'm just going to move these along the line, okay? And you're going to say, well, your leads are bad. And I did suspect that. So here I've got a Sears Craftsman. This one says open loop. This one's saying 0 ohms. So that's interesting there. What's going on? I'm still connected to that. And so then I went to this one. Here's a very expensive meter. I'm thinking, well, surely that meter should give me the correct value. And it's saying OL, open loop. Okay, well, that's interesting, huh? And this meter here is, geez, I don't even, $700 or something like that. And, okay. So finally, I got 188.4 on this meter, okay? But I don't need to spend $700, $800 or whatever it was on a meter, but I finally got a value where all these over here weren't giving me 188.4. So that eliminates the whole problem of it being the leads, but I'm not bringing this meter out into the field all the time. So I finally got a winner here. So these were all giving me open loops. So now let's jump over to Radio Shack here. Let's see what Radio Shack has to say. Radio Shack 187.4, 188. So this yay for Radio Shack. Okay, too bad for Fluke. Okay, so this was a winner. Okay, let's go to this guy here and plug them in. And oh, I'm not on the right mode there. There we go. I got 189.2, 188.9, 188.7. So we got a winner on this meter, okay? And then I got this. I've been telling you guys that I'm going to be doing a training class on how to use meters and how to interpret electricity. And so I specifically bought this little meter to do my training class, thinking, okay, well, it's not you're looking at hundreds, if not thousands of dollars in meters here, and I don't want you guys to, plus the oscilloscope wasn't cheap. I don't need you guys to invest all this much money. So I found this, and I'll send you a link below on this meter because this meter got it right. So here we're going, 188.7. Okay, so out of all these meters, only 4 of them is the point. Only 4 of these meters were giving me the correct value that I expect to see on my through my ohms thing here. And so that was a big eye-opener for me. So if you're a tech dealing with this and you have your Fluke 325, which I think is everybody's best meter, of all my meters, this is my favorite one, it was not able to tell me, for whatever reason, it was not able to tell me the value of this sensor. And that was a huge wake-up call for me. I'm like, whoa, what is going on here? So I started digging around. So from now on, I'm really curious about what's going on. And it wasn't just this meter. This one is hundreds of dollars. This has got the Bluetooth feature that'll do data logging, and it wasn't even able to tell me the value. I used a Sears Craftsman for a number of years. These were a couple $100, and it wasn't able to do it. This is one I used in airports, when I did the airport conveyor automation stuff, and it wasn't able to get it for me. I plugged it into this one. This one I've had since the early 90s, and it wasn't able to give me the ohms value. This one I tried, but the battery terminal is broken off on it. But it's, again, so my point, I had to go with I don't know how much, it's a 787. You can price it, but there's no reason for you to buy this unless you're doing process automation. But yeah, this little guy right here. So for the rest of my thing, I'm going to be using this guy. And when I do my class on how to use these and everything, I'll probably be using this one right here. It's small, it's compact, and guess what? It was able to get my value. Now, it's not as fast as these Flukes. The Flukes are very quick in their evaluations. This guy took a little bit longer, but it's okay. So here's a takeaway. One of my takeaways that I wanted to share with you guys is the meter told me, my everyday carry meter, the 325, it basically told me that it's open loop. So therefore, I might make a false assumption that this sending unit is bad. And I did originally. And then I compared it to this sending unit, and then that sending unit over there on the tank. And it said they were all open loop. And I'm like, but when I do another test, which I'm about to do with the water over here, it worked fine. So I knew that this was working. I just wasn't getting the value that I expect off my sheet here. And so that's when I said, well, let me try another meter. And then I started digging, and I finally grabbed my old Radio Shack, put a battery in it. It gave it to me right. And I'm like, well, let me see if this little guy does it. So anyway, that's a takeaway I want you guys to take away from this. So I'm going to put some of my toys away, and I was about to connect all this to the oscilloscope to see it here, but I'll maybe do that at another time. But that would have been a fun thing to do too, but I don't have the time right now, but that'll be fun. So let's move along now that we understand how to test our sensors, okay? So the takeaway from here we have our sheet up here on the top. Take a snapshot of that. It's going to tell us that red to orange is 0 ohms, red to green we want 68K ohms, red to yellow we want 188 K ohms, okay? That right there will tell us if our sending units are good. But make sure that you use a meter that will give you the right value, okay? So now let's move on to the next part of our little show here. So what I'm going to do now is do a little demonstration on what would happen. So I've got a little pail of water here that will work for our purposes. And so all these wires on the back, I've got a large deep cycle battery here that's connected to the red and the white, the plus and the minus for the monitor panel. So we had established earlier that red and white were 12 volts plus and 12 volts minus, and here we are. We're connected to that. And then that left us with a brown, a gray, and a blue, okay? And then we also established that the wires that are coming from, I'm going to call this a sending unit, okay? I don't know its official name. It's a K101, okay? But I'm going to call it the sending unit. We established that the color codes, yellow was 1/3, green was 2/3, and orange was full. We've established that. We demonstrated how to do how to test these. And then red was the signal wire coming from these. So red from our, here I have one set up. Red from this signal wire is going to now connect to either the brown wire, the blue wire, or the gray wire. Jeez. Yes, depending on which tank I'm connected to. Okay, so I just want to make sure that you understand where I'm getting my wire connections from. So these are the sensors, and what I'm going to do is drop in my common into my bucket of water. Okay, gray wire represents gray tank, so I'm going to hold down the gray button. Okay, now, two things have happened. I'm sending, I've illuminated my empty LED on my display, and I've got a value of 8.4 on my meter and 1 empty light on my monitor panel. So then the next color we're going to drop in is yellow, which should illuminate our next phase. So I'm going to drop in yellow, And here I have 1/3 value and 6.5 volts DC. So the voltage was going down. That's how this knows what to do with the value that it's getting. Now we're going to go with our green wire, which is 2/3. I drop it in, 2/3 lit up value on my monitor panel, and I have 4.8 on my meter. And then the final one was orange, which should show full. We're gonna look at our meter. There goes full, and I've got basically 1 volt DC, okay? So we'll pull these back, my finger. We'll pull these back out one at a time, and we see the values going down, okay? So that would be how this is, they're all referenced to the ground, where the voltage divider within, the resistors within this are giving us a resistance value, and there's continuity between these sensors, just a teeny bit, but that's enough for us to make this work. I think it's 170 milliamps or something like that. Okay, so I'm gonna take my finger off this. So now I wanna try my black tank monitor panel. So I'm gonna take the gray wire off, and I'm gonna connect to brown. Brown symbolizes the black tank. Black tank's gonna be toilet, basically. It's going to have a 3-inch discharge. The gray tank could have a 1.5 or 1 1/4 inch discharge. And it's everything but the toilet. So that's sinks and showers. I'll do a whole nother video on tanks and valves and things like that. So here we're going to now do our black tank. Okay, so I'm going to hold my finger here. So now we show that it's empty. Meter just turned off. Let me turn it back on. Okay, so I'm not pushing my button. I push my button, and I have 8.3 volts DC. Here's my common, and so now we're going to simulate. We went up one little light here on my meter, on my monitor panel. We're at 6.5. Go to green. Went up another light, 4.9. And then I'm going to go to orange, full 1.2 volts DC. So let's take them back out. You'll watch these lights go down one at a time. Okay, so there's that one. All right, now here's the climax of our show, which is what started this whole thing, and you'll understand here in just a second. So let me grab my blue freshwater tank, and we're going to now connect the sending unit's red wire to the monitor panel's blue wire. Okay, so same test. Here's fresh right here. I push. I have one light. 7.8. Now before I was getting 8 volts, 8 and change. I'm only getting, oh, I'm right at 8, but it just seems a little lower to me. But anyway, so I'm doing that. Now let's simulate. The yellow wire was 1/3. Whoa, 2/3. I got one yellow wire in my bucket, and I've got 2/3 value and 5.4 volts. Okay, well there's something wrong there. And now I'm going to go with my green, which should be 2/3, and green made me go full. Green told me my tank is full, even though, according to green, it's only 2/3. Just according to yellow, I'm only 1/3, but the sending unit is telling me, or the monitor panel, or somebody's telling me that my tank is 2/3 full when it's not. It's only 1/3 full. But I'm going to drop in my next sensor, and it's going to tell me I'm full when in fact I'm not. I'm only 2/3, which we've established. Now I'm going to put in my full sensor, and it's going to tell me it's full. Now we see the values changing on my meter. 3.7, 5.4, and 7.7. So what's going on here? Now, if you were to go to the forums, they are full of people, full of RVers, good people, that are upset because their tanks, or their monitor panel is giving them incorrect information. You might be one of them. Maybe that's why you're watching. I know I've certainly had my frustrations with I've been full-timing since 2007, and I have had around and around and around with these things. You blame it on the sensor. It's the sensor's fault. It's the sensor's fault. It's the sensor's fault. The sensors are dirty. The tanks are dirty, and everybody is attacking the tanks and the sensors. And they've even maybe gone so far as to put these sensors in their tanks, gain accessing to their tanks, put these in, and the monitor panel is still giving us false readings. And let's demonstrate that real quick. I did not do this in any rehearsal, but let's just say that we're going to stay on the blue wire. And wasn't it the yellow that was giving me 2/3? Here, let's just check. Okay, so yeah, yellow is supposed to give me 1/3, but it's giving me 2/3. So let's put on a miracle probe. Let's see if changing my probe has any difference in my results here. I wonder if they changed their... Oh yeah, those are fine thread. These are coarse thread. Yeah, fascinating. Okay. So there's another takeaway. The miracle probes have a different probe. So I'm going to drop this one in. Here we go. This was fresh. Let me get my fingers associated right. So here's fresh. Well, that's interesting. I don't even have anything in. Oh, it was my fingers. Okay, my fingers were what was giving it false. Check that out. So my fingers are wet, and somehow I'm completing a ground with that white wire. I'm checking something. Okay, it's because my thumb was touching the back of this. Okay, so let me hold this a different way. Oops. Okay. So there we go. My thumb was touching the back. I was wondering where the ground loop was coming from, but it was going through me because I'm touching the back of the motherboard. So I've changed my sensor. What I expect, because I knew my tank was empty and I knew my tank was at 1/3, so I did all the trouble to change my sensors out. I put a brand new sensor on. The thing's still telling me it's 2/3. So everybody's yelling at Hirschmer, oh, the sensors don't work. The sensors are crap. They don't work at all. And you know what, folks? It wasn't the sensor. Right out of the box, this is brand new. This sensor, the motherboard, is the problem, okay? So that's why I wanted to go through the trouble to explain to everybody how to diagnose your sending unit, okay, how they work, what kind of voltage you should expect to see, that there's nothing to them. And even if I were to change my sensor, it didn't change the value here. And so everybody's saying, oh, it's the sensors, it's the sensors, it's the sensors, clean this, do that, change the sensors to this. The whole time the problem was here. This was the problem, okay? Now that we understand this, we can stop just pointing fingers at every other thing out there. We now know how to diagnose the problem. And if the sensors are sending us the correct value based on the sheet that we did, and remember, I had to go through a whole bunch of meters to find one that would work. But if the sensors are sending us the right value, it's got to be this, okay? Well, folks, that's really what I wanted to cover in this video. I really wanted to stress that when your monitor panel is giving you incorrect information, don't automatically assume it's the sensors, it's its tank. In this video, it's something I discovered. I thought there was something wrong with my sensors, and then my takeaway from myself was like, wow, the meter's not giving me the right value, and I expect that meter to be my go-to. And then when I went a little bit farther, I discovered that on this particular monitor panel, that the fresh water was the thing that was telling me that there was a fault. And so my whole process was to diagnose and figure it out. And then when I discovered that the problem was in fact the brand new KIB monitor board, that's when I dug a little bit deeper and did some things to put a package together to share with you guys. So that was it. So if this was helpful, give us a thumb up, share this with your friends that are also having problems with their monitor panels, and get some information out there to properly diagnose these systems before we just start pointing fingers at what we think it might be without having any diagnosis at all. If you know me and you've watched my videos, you know I like to follow the trail and prove things out as we go. And the trail led to a brand new monitor panel. So at this point, we'll be contacting KIB, sending it back to them, maybe even letting them watch this video, and maybe they'll make it right for us and send us one that we know that is working. And so if this was helpful, just share us the love. One thing I'm really enjoying doing is hearing where everybody's located. So you could just give us a comment and say, hey, I'm in such and such a place, such and such a place. What's really exciting is we're getting people from all over the world. And it's really, really cool to hear where you guys are. So this is Darren, Joyce Washington, signing off until the next video. Thank you for your time. Bye.